Do 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 do. Oh. So we're gonna see about finishing up this pixelize bit. I did some testing, and it looks like pixel processor is just better. Um, so we have our demo graph. This somewhere in here. Oh, 221. What was the one I was using? Stone. Like a brick. This bricks. So our pixelize. Bring that in. Demo palette. And then this other one. Same thing. Look pretty similar. I have a standard palette, 256 palette. Okay, so these look pretty much the same. This one's calculation time is a little bit faster. This pixel fidelity isn't as good. So do look really similar. Calculation time, the pixel processor is a little bit faster. If we change our engine, we switch over to CPU. Okay, they start to get a little bit closer, which I thought was interesting. Let's go up to 32 on both. Okay, they're close. No, they're not nearly as close. 67, 12. Okay, let's go to 256. Woo. So I know that pixel processors are faster on the GPU, but I don't think the FX map gets any GPU acceleration. So I was thinking, oh, well, I build an FX map, and then it's going to be reliable across GPU and CPU, which it is. It behaves pretty consistently around the same. But once you start to get up into the larger sizes, so this is 167, which is, it's pretty slow. This is 1,000. That 167 doesn't look nearly as bad against that 1,000. This red has actually shifted all the other colors here. So this calculation time is relative to the most expensive thing in the graph. So this is 5.8. That's good. It's the lowest. Well, this is the lowest, but that's reasonable. So that is with a palette size of 16. So let's up our palette size to, this will probably crash Substance, 256. This one's waiting on that one, I think. Or we'll do them separately. It's rendering. Rendering went away. Let's cancel this rendering. Let's see if we can switch this one. And we're doing the most the accurate color. So there we go. Okay, so the pixel processor with a 256 sample. So basically what it's doing is it's crunching it down and it's sampling 512 times 512 pixels times 256 to find the closest. So for every pixel it goes in, it goes whoop. Okay, the color of this is this tan or whatever. And then it goes, okay, well, which color in my palette? And it goes through every single one in the palette in here, goes through all of these, and it finds the closest one. Let's say it's this, and then it returns that back. In order for it to get the closest one, it does have to go through all of them. It can't go through and be like, oh, this one is within X margin, and so it's the closest, because there could be one farther down the line that is closer. And this one's still going. So that's pretty expensive, but we are on the CPU. So this is like a worst case scenario, which is, I'm not running an optimized setup, but crunch is pretty hard. 16,000 milliseconds to calculate that. That's like an export routine. Go export this into another application, process it, and then bring it back. That is crazy. So we switch engine. We'll go back to GPU. Just make sure that actually switched. Okay. And then we'll calculate. This 2200 doesn't look so bad against 16,000. It's like, yeah, that's green. So now on the GPU, it's down to 18. This one's still going. Okay, and so it's at 15. So cool. So the real, because I was running both, the real calc time on this is 11. So let's see. So it's pretty unworkable at the larger resolutions that you might want to pixelize at in the FX map. Like, it's like 15 seconds to calculate a 256. Yeah, so slow. So with that testing, I think I'm going to switch it over to a pixel processor, because on the CPU, where the pixel processor is slowest, it's still faster. So, and it allows you to actually go up a little bit higher on the size, because the FX map is a hard limitation where you cannot go above whatever 1,000,000 instances of whatever you're duplicating. So And if we turn off accurate color, then it's even faster. So let's take a look at how to do that. And before I delete this, I want to make sure I have everything in there that I want. So we're going to rename this. Yeah, let's update it. So one of the things that I need to do to keep this performant that I actually discovered was doing the like crunch it down step before. So in here, I can control the filtering of it. So if we tie this to filtering, should pin this, jump back over here. So here, if we change our filtering, the calculation time changes a little bit. Let's go to accurate, which is good. If we go in here and change the filtering of this to bilinear, boom. We just lost so much performance. So we'll switch this back. Nearest. 10. Bilinear. Ooh, interesting. Now see here it's saying it's really expensive. Okay, so let's drop this in. Nearest. It could be totally wrong, which I'd be happy about. Okay, it doesn't seem to matter that much once we resize it. So we have our target size and then we shrink it down. But the 2D transformation 2D node is much faster. And you can control this approach. So we're just going to sample nearest, keep it as performant as we can have it. Okay, so let's look at the pixel processor versus the FX map. So I'm not doing this currently, which I probably should. I think that's why we were losing the lines at the lower res. So if I look in here, basically what we're doing is we're plotting each box across the FX map, and then once we get its location, we go and we sample the color, and then we do some input weighting, and then we run it through our color conversion stuff. In the pixel processor, you don't have like where each box is, you have the pixel itself. So this tells you where it's looking. So in the pixel processor, it looks at like a chunk of pixels, and then it has all that info for each one, and it's processing those chunks together, and it basically has where that position is of that pixel. This is which pixel, get its color, and then convert it. And then all this color stuff is exactly the same as before. So I added some short circuit logic, which helps speed up the process if you have fewer colors in your palette. So that was one of the takeaways from the last one, was how do I make it more performant on smaller palettes? And basically the way that that works is it uses Designer's built-in feature that it's basically working backward from the output. So it says, okay, what do I need to do and then it kind of follows these. Let's say this one, it needs to get like all of this info into it. It goes, okay, cool. So let me go get that info. So then it traces this wire back, and it gets it here, and it goes, okay, I need to go based on this decision to get this or this. And so it's evaluating that, and then it's tracing that wire back to the next spot. So basically what it's doing is we do this part, and we always have to have some color in our palette. So this doesn't have any logic in it. And then this one, it says, wait, is the index that I'm trying to pass in, so going through the palette, whatever number this is it greater than my max number based on the dimensions of the palette? If it is, then you should just use info from previously. So just go use whatever we already calculated. If not, then go get this info. And it does that for each one. So if my palette is a 4x4, this is first 4x4, each one of these says, oh, go get the previous data, go get the previous data, go get the previous data, go get the, all the way up until we're basically only calculating what goes into this. And then inside of this one, we have similar logic that says you're only going to sample and convert and do all that stuff if your index is less than the max. So otherwise, just use previous info. And if all the data is basically the same, we'll just get the same color. It will check against more, like this. There's not really a way to make this more performant because you can't make assumptions for both the scenarios of like half the info being all the same and then sometimes it being not the same. So this one does check through all of them to return the min, which if all of this info is the same, it'll basically stop at the first match and not check in any of the rest. So if it's a one color palette, it'll basically stop here and then leave. So what that looks like in here is if we change our palette size, so we use this palette and we change to a 4x4, then that time drops significantly. And then we can say that there are empty rows, which will basically, up to the first color, because we have to have at least one, cut the colors down that are in that palette. So if we go above that, then it's basically only doing one color. So you can see the calculation time getting a little faster. So that's what we're doing in both the FX map and the pixel processor. So the next step, which I think is important, is getting the directional blur approach back in, because it helps like, kind of average the colors since we're pixelizing so much. So we're going to copy these, not duplicate, copy, paste these. So this will kind of average based on the sampling. But we're going to try this. And this may or may not work. I don't know. So this point here where we're sampling the pixel, we're going to try sampling the other images in the same pixel. And then we're basically going to average them together, but we're going to weight the default image one higher. So we're going to multiply that by 2. Actually, we're going to just do we have that parameter? We don't. We're going to do that's a, I was getting into a name that's better fit for a description. So this is going to be weight. Okay, so then inside of here, we can get that float. And then do merge float 4 because we want to weight each channel the same. And then we're going to multiply it there. And then we're going to add this to it. Actually, let's add these two and then this one. And then our average, if we were to average these, is this plus our weight. So there are 2 of these. So then we do whatever the input weight is, which could be 10, 5. But that needs to get added in, otherwise our average is going to come out much higher than it should be. So, and that should be that. Save. And then open up our test graph. Because it's sampling more for each one, it is going to go up in cost. So it may make sense to, when you set it to 0, it's just assuming the neighbor, or rather it's assuming the sampled. So now it's 50. So if we go in here and edit this, and instead we only sample 1, then it's super cheap. Because on like a 512 by 512 image, we're sampling that times 3. So we're going to do the kind of short-circuity type stuff. Group these together. If our input weight here equals 0, then just use this. We're also doing more math, which is a little bit more expensive too. So if our weight is 0, then don't worry about sampling the neighbors. Now we got our performance back in the 0, which this weight is a little bit weird. We should probably set it to a float, but integer steps. So we come back here, we have our input weight. This filtering we should have be a drop down. So max, we're just going to say 10, because you can just set it to 0 if you don't want the neighbors to be used at all. And then we're going to change the step to 1. So even though it's a float, it's going to move like it's an integer. And yes, you could put a fraction in and it would work. It's not going to cause an issue. And then change our filtering here to a drop-down list. And I can never remember the order. Filtering 0 is bilinear, 1 is nearest. So filtering 0 is bilinear. And then 1 is nearest. We're going to set nearest to the default. And then this needs to be the same filtering setup. Okay, cool. So we're using the transformation node to do our sampling dirty work more performantly. At this size, the filtering doesn't matter as much. One other way that you could do the pixelization is to change the way that you're sampling the pixels. So this was one of the things that I tested, and I didn't feel like it was faster than just crunching it with the 2D transform. So each position is giving you the fraction of its left to right and top to bottomness. So, which you usually think of as like a UV or a position map. So let's visualize that real quick. Vector 4. Okay. Well, if we turn this to 0. Okay. So then it's going from top left to bottom. It's 0 to 1 and 0 to 1. So then out here it's 1 and 1. So what you could do to pixelize is basically limit the square that you're able to sample. So we have our target size integer, which we're just going to set. And then we divide. Well, in order for us to get fractions, we need to go to float, and then we add a float. So 1 divided by at least 1. So then if we do a modulo, which would give us the remainder, So we take our x position divided by basically the interval, and then we take our y position, do the same thing, and then we subtract the remainder from what the actual division is. So we're going to take our y divided by that. Oh, because it's 1. That's fine. So then we have our squares. This is an annoying way to do it. Let's just use integers for the way that integers work. So I'm going to take this thing, multiply it by that thing, and then divide it by this. Okay, we're expanding the scale, and then shrinking it back down. So we take the thing, we multiply it to get our scale, divide it back, floor it, and then put that in. I think that math is correct. We'll see. Almost. You have to divide it back down. There we go. Alright. Now we get our squares. Although it is going, let's see, ceiling. Yeah, we don't want ceiling. Alright, so basically what this is doing now, just want to make sure, so our position is 0 to 1, multiply by 2, so then it's basically 0 to 2, divide it down, floor it, which is going to round it down to the nearest integer, and then divide it again so that we get a 0 to 1 range. It's almost correct. It's not correct because multiplied by this. Alright, anyway, so basically what this is doing is for every pixel here, it's getting a position, like just looking at this X position, right? It's getting some decimal. And then we do some math to it so that it's always sampling the same pixel. It's basically rounding all of these down to a common one. So all of these are getting rounded down to 0, 0. And it goes to this one, and then all of these are rounding down to 0, 0. But the issue with this is every pixel is still sampling 1. So this 1024 by 1024 image is sampling 1024 times 1024 pixels. In my version, here, we shrink it down first and then sample the pixels to get the correct color based on the palette. So we use the sampling and crunching down the size so that we're only sampling a small number of pixels, which I think is better. Mathematically, it seems like it's better to sample fewer pixels than more pixels and just round, because even though you're sampling the same pixel, it doesn't cache that value for that pixel. So it says, oh, I'm actually going to sample this one. Oh, I'm actually going to sample this one. And then it does that for every single one. So you're sampling every pixel anyway, as opposed to just the number in the size image that you're working with. So I'm going to turn the limit up on this and then see if Substance crashes. And then probably move on to something else. I'd like to figure out the dithering portion, but I haven't been able to figure out a good method for that yet. So now we have a palletized, because it's not pixelizing it, right? It's the same dimensions. So it's just choosing colors from the palette. I could give it a different one. So then this image in 256 mode is this. Giving it a quantized palette is not the best way to do it. If I wanted a 256 color this with the standard quantized colors, it's much faster to just quantize the color that comes in than verifying it against a palette. So it's definitely a case where you give it a palette and then have it figure it out for you rather than just quantizing the color, because we have quantize in here already. So I could say that you're limited to 16 colors or 8 colors. And then you get something that's really similar to using this so just quantizing it, if you just want to limit the number of colors, is a much better approach. Two. RGB split. It's basically doing this for each channel. this is 3. Okay, let me rename this so that it's not BP. And then we can delete this. Just do that. And then rename it. Rename it. FX map. And then I don't think I'm using Sobel. Remove that. Dithering. Didn't figure out dithering. Remove that. Gonna move some stuff up. So bring this in, and it's black. And then do. Oh, wait. Okay, one more thing before we move on. And that is the palette handling for missing columns. So we can basically shorten the grid if we want from, let's say, a 4x4 to like a 4x2 grid using the empty rows, but we want an empty columns. Which is dog is so weird. And then minus the empty columns. It's kind of weird math, but and the max is going to be 16, and the clamp it, because that's weird. Okay, then it's a integer. Yeah, should be an integer. I'll go in here. I want to get that integer. Oh, weird. Weird names. Okay. Empty columns. So then here we just subtract empty columns. And we should make sure that the default is 0 on that, not 1. Let's see if this breaks everything. Empty rows. Okay, I kept it. Cool. Cool, cool. And then we have a weird like target underscore size. I don't want that. And weight, filtering, accurate color, palette size, and 2 rows. Okay. And then go over here, just to test it real quick. Bring that palette in. Do Cliff Stylized Mossy. Bring that down. Whoa. That. Oh, okay, 4x4. I'm like, what the? 16 by 16. Make it a little larger. Accurate color. Take off half the rows. Off half of that. So what this should be is sampling between black and red. Can remove this mimic. To multiply the number in the x, the empty rows, subtract that from the total, and then subtract the empty columns. And that's it. Get more of the colors back in the first row. Am I doing something in here that I should not be doing? Nope. So it's 16 by 16, so 256 minus 16 times 16. So it should be 0. I always sample at least 1, because it's 0. Okay, the short circuit logic might be slightly broken. But I can deal with that later. And then let's do contrast luminosity. Also, having a more performant pixel processor helps in real-time testing of this kind of stuff. shifting your values around to get a different palette. Okay. Cool. Done. Done. So close that. Okay. Save this. Close this. So, my backyard looks like this. And I wanted to see if I could throw something together in a few hours that's a good start on this. So I took some varying shots of different closeness. I want to see if I can make this substance. This scale is probably closer than I want. It should probably be smaller. So let's do it. Law. So my starting point is always a sculpt, basically, to make sure I'm getting the right shapes. So the first thing I want to do is try to make these little plants. So if you look at it, it's kind of this oblong shape, and then it has this stem that comes off of it. So these are kind of these like teardroppy shapes. So probably gonna just start off with the paraboloid and then squish it around. So I'm going to give myself a little bit of room to work and stick other shapes on there. I'm basically going to histogram scan it, but I want to be able to control the shape of the edges a little bit. This edge, so if I move the middle, then I can kind of like round it over. So it has a little bit more shape to it. Anytime you use a height map, you kind of want to have a little bit of, or a normal map, you want to have a little bit of shape. If you go all the way, then it gets really weird looking. You start to get this tearing, which you don't really want. Just having a little bit of shape helps the work a little bit better. So it'll be symmetrical, so we'll mirror it. That way I can work in here. Turn tiling off. Does this have a... doesn't... Okay. So then I need to scoot this, scoot it, scoot, scooch. So if we look at this, a reference here. The shapes kind of come off the end. And then it's kind of the same thing again after it's shrunk down. So then if I take this and basically do the same thing, do this. Whoop. So here, tiling, and then we're going to do another mirror. So this needs to be shrunk down, and make sure we're keeping it centered. And it has a little bit of a kind of a teardroppy stem that comes off of it. So it has like a piece that fills in here. Do this shape right here. And then these kind of come off of that. Oh, these ones have like lobes too. Okay, so it's something more like this. And I think I would want to pull these up a little bit. So this shape, this one here, is a little incorrect. I want to pull the bottom in a little bit. So before I mirror it, I'm going to do a directional warp, then a linear gradient, and we're going to flip this 180 because I want to basically push the bottom in, and then it curves. So the warp is going left to right. So I want to push that in so it goes warps this way. And then I need to bring my warp center down. Change the profile and warp it like a lot. So we're going to go like 120. And I'm trying to find where that shape stops. So I basically have to kind of shear it first. Doing it all the wrong way. This is what I want. Then change that profile till it sweeps in the way that it should. So I'm looking at this shape here, and then the reference. one of the challenges is that this cuts it off in the middle. So, because I'm warping, I'll basically have to shove these over. To get the warp to work the way that I want it. And then shrink everything down because it's running off the screen. Looking at the warp and how it's pushing it off out of the way. So, looks like directional warp needs to happen first, so it doesn't get pushed away. This is where I should just have like a plant tool. And then doing leaves would be a lot easier. Enough math for today. And there's actually, looks like this should be shaped too, so we're going to shape that too. And this also needs to be warping to the right. So then I'm going to change where the start is. Push it a lot. So I'm looking where that kink happens. And then I can basically round it out here. Get a little bit more natural shape. Okay, the last thing is that we need to stretch the bottom down. I can keep using the same gradient as long as I'm warping in the same direction. But because I am not anymore, mirror, I need to have a different gradient. So this one needs to go to right. And then we need to warp down. And let's do this. So we want to warp from the middle of it. Warp's too intense. I can't see where that kink is happening. I don't want this. So just looking at the bottom, the shape that I'm getting in the bottom is basically what I want. So then I need to slice the top of this off so that it doesn't warp the top. Ah. So then I can bring the top down, and then it doesn't warp the top. Because the strength is black and white. So if it's black, it's not going to warp it at all. Okay. So in here, and then here. Then I need to transform this again so that it goes where it's supposed to go. This is where it's not really procedural. You're just building it at this point. I almost feel like this warp should be going the other way. Okay, so this shape is really the one we want here. And then we need to pull the middle down again. Let's see if this will just work again. Okay, change the direction. It will reslice it. So that looks really wrong, but we just chop the other side with the mirror grayscale. Ah, sorry. Ugh. Snuck up on me. I didn't blow your guys' eardrums out. This shape is a little too tall. Okay, so this shape's a little weird. And then we need to pull the middle down again. Let's see if this will work again. Nope. Where it needs to happen is different. That's unfortunate. Don't want the edge wrapping around like that. And then take this and see where the slice should happen. Oh, unfortunate. Because I'm wrapping it around. I'd have to run it through multiple. Ugh. What's this? So, in order for this to kind of properly work in a splatter node or tile sampler node, we need it to feel like the middle of it is growing out of where it is, and it's always based on the center. So all the tile placement, all that stuff's based on the center. So you want it to feel like it's growing out of the center properly. I'm just going to give this a little bit of variation. So I could make this into a graph. This is going to be tiny leaf. Oh, I should have the transform 2D in there. Centers it and set an output. Nope. Don't need the stuff we don't need. Clean that up. Save this. So then, tiny leaf. And if we change the seed, we get slightly different leaves. Trying to see where the veins are on these, because they definitely have more shape than I've built in there. But what's nice is I could go and change this graph and add that detail in later. So we want to make little clumps. So these come in like, for the most part, 5. Looks 5-leaf clumps. So do a splatter circular. The image input, and then there are 5 of them. Then change our radius and our size to so they have these stems that kind of come off of them that I should probably put in, because those are what tie them down to the middle. So we'll go into our tiny leaf, and so we move it, we get a little bit more room. And then put a stem in there. Probably just use these. Chop one out of the other. And blend these in. Oh, and mirror. And then we'll have to recenter it. That's weird. Oh, that's because of directional warp. which should happen at the very, very end. Should probably use... Oh, no. Oh, no. I know I posted a note in Discord a long time ago. Haha. Jump, jump, download. I should put this in my library. If you guys would like the node, I'm going to assume that this works. It may or may not work. If you want to try it, let me know. Documents. Oops, it's library. Cool. Don't need this. Close that. No. Okay, what this does is it takes the thing and it centers its bounding box based on some infos. So it was this, and then it scales this up and centers it. I might want to turn off the scaling part, but and then I should be able to cut this in half and offset it by 0.5, and that will have it barely kiss the edge and center its stem, right? Because this fills it up all the way, and then this puts its bottom basically back at the center, and then I warp it. Whoa, that's an issue. Absolute H&V tiling. No, not there. Absolute, no. Let's have input here. Get the tiling back. But we need to warp it down. Which will move the center a little bit, but that's okay. Okay. There we go. And then change the radius. Whoop. So on these, there's kind of the middle one, and then the two, and then they get smaller, smaller. It's like all of them. This one, and then this one's like, these two are 75-ish% of that size, and then this is about half the size. Every single one. So, I don't know if this is going to allow me to do what I want to do there. So I may just do this. And do one for either side. And then I might as well have another different one. And then I need to do the same thing for the next ones. I tweak the placement a little bit so that the stems kind of occlude each other the way that they're supposed to. So then these are presumably at different height, different shape, right? Like if we look at this, they kind of grow out from the middle and up and then kind of flatten out. We don't have any of that height info in here. So we probably should. And I'm going to use a shape and subtract it. So try thorn. See how that works. Things aren't exactly centered. Centered. Oh, I call it scale something. Like a weirdo. I don't know if thorn will work. Let's try like a paraboloid. Just scale it down. That cutoff is weird. And try levels. Change the I wish create graph from selection actually snapped it to the grid. That would be really nice. A few random seeds, and then we're going to do a tile sampler just to see how well these play in that setting. I find that the pattern index works much better than using random, as long as you randomize the position enough. Um, ultimately, things will probably be put into clumps using like a effector displacement type of thing, but for now, it helps reduce cases where it's just clobbering the other one because they're kind of growing in a stacked order on each other based on the index, and then as long as you randomize the position enough, you won't get weird scenarios where it feels like it's just kind of like the stair of stuff, which you don't really want. It makes it look really weird. Okay, so there's some plants kind of blocked in. We have these sticks, lots and lots of sticks. And they're all kind of curvy and bent and pretty random. And then they're kind of got this lumpiness to them because they're these cedar frond branches. I'm going to try the scratches generator. Because you can make them wavy and bent. So if you change the distortion frequency, that's basically like the size of the purlin. So you change that pretty low, then they just get kind of wavy. And then we don't want the frequency to vary a whole lot, so just a little bit within the distortion range. And then we make them really wide, and then lowish width random, because these are all pretty consistent width. And then we have like these big branches, and those will probably be a separate pass. And we probably just want fade start or end, not start and end, because then that'll make basically every branch shaped kind of like worms or snakes or whatever. We want to make them pretty big. So cool. And then the segments per spline, you can kind of see in the background there. I want that pretty low because that'll actually kind of give me this segmentation that's happening in the branches. Ton of them. Totally random. Let's look at the distortion against the length again. Now that they're longer, you can vary the bend a little bit more. So if we just plug this in here, take a look at it. Looks okay. All the shapes are V's, which we don't necessarily want. Let's see. Start end just gives a lot of intersection. Okay, so we need to change the profile of these, which we'll do with the levels. So these are all this kind of weird shaped V, and our branches are round. So let's see if we can round those over a little bit. And kinda roundy. Curves might be the right decision. Definitely want that luminance random. There's a little bit more structure, just looking at the reference with the way gravity and all that works to the shapes. Kind of get intertangled and pulled in a direction. So I think I'd like the slightly simplified noise. It gives a little bit more area of rest. Kind of are in these interwoven clumps and then just kind of open areas. I'm going to rough these up a bit. So then these plants are kind of growing up through, which means that their highest point is going to be higher than their highest point. So one of the things that happens is this, like, the leaf is kind of cutting it out. We don't want that. So what we can do is a non-uniform blur. Take our sticks and blur them in those areas using our plants. And we can histogram scan if we want to get a little bit more contrast to make sure we're hitting all of them, and then blur that in. And then our blending mode has to be add for it to work properly. Levels this, and then this in there. Otherwise, you'll still run into that max issue. So switch this to add, and then this is where 32 bits becomes super useful. So we do want to pad this back a bit. So the sticks recede, and then the plants enough height map to stick above them. So here, we're not doing any scale variation, which we definitely should. I'm gonna make this one. Those are super small. So then the other thing that we want to do is make sure that the center of the plant is not growing through the branch. Right? So then we're going to use the mask on this, and we're just passing the branches in, but we want them to not be growing on the branch. So then we have to invert our mask, and then chop off the ones that are growing on the branches. So as long as the center of this little clump is growing up in between the branch, it's okay. Here it looks a little close. I'm going to make sure this is high enough that we prevent that. And then, because of the warp that we do, things might get a little off center. which is okay, as long as we're aware of that. So then we have the plants growing up between the branches and then kind of flowing over them. There are probably too many of these little plants. I think I want to kind of cluster them a little bit more. So, Bruno Afranes, God, I'm probably totally butchering his name. Yeah. Afonseca. Totally butchered it. And I'm still probably butchering it. But this node, super useful. So you could kind of make it yourself by trying something cheeky like this. 2 blue. And then you're like, oh yeah, it's the same. See? Yeah. Oh, I want to invert. Okay, well, then we'll do a normal invert. Okay. So, let's invert. Okay. But then he has the ability for you to change the sampling, and you can change the direction in ways that make sense in the tile node. So it's just so nice to be able to have things like orient the way that you would expect. So we are going to use a vector displacement to push things into clumps. So now we have a little bit more clumping. We still have some extra ones that are just out there. That's fine. We have that here. So we can have these clumps and then these little other ones, sporadic. So now we have something that's more similar to that. We need like kind of a core soil. Actually, in the references, basically can't see to the dirt. So here's some dirt. We need something that kind of feels that way. So we could build up another layer underneath using scratches. We can increase our number a lot, increase our random a lot, and change our length, which I believe is scale, a lot. And then here's where we could do start and end. And we kind of look at these like little sticks. Scale randoms much less. There we go. Wow. Okay, so we're going to use this to hopefully fill in underneath here a little bit more. We want to use this. We want to put this all together before we put the plants, because the plants need to grow up through and sit on top of everything. And using the add blend mode, we want these little sticks underneath too to be integrated. So then we'll use a height blend, and these sticks are on top of like these little kind of needles, which I'm going to change their width a little bit. We'll change this height offset, mess with this. Then we have another layer underneath. We change the segments. Does that smooth out? Not really. I think with this, we're just going to do a non-uniform blur on it using itself. This is the like the ones that are starting to decompose and kind of get pushed down more and more and more into the dirt. Then we need to make kind of a soil looking. So I'm going to use this, clouds, and clouds, and dirt. Probably one. Okay, so if I take this, combine these two with kind of a 50%, and then smooth it out. This gives me kind of noisy soil. I can change the kind of shaping of it, how lumpy it is. And then it's important to have areas of rest in your materials. So we're just going to totally smooth it. No. We're going to see about just kind of knocking the super high frequency details off. And then we're going to blend this back in. I'm going to try to use this dirt as pebbles. Kind of works, but these need to be blurred over a little bit. I don't like the indentation-y thing that the lower contrast gives. It's a little bit weird. It's getting a little less like rocks. Let's try different dirt, like a lower frequency. Looks better, but we're gonna knock the pointiness off them. Alright, so I got some little rockies in soil. Then we're gonna this should probably just be the larger sticks, the way that the logic is kind of working in the reference. Alright, so then I'm going to blend all the sticks and stuff. These should all probably be 32 bits. Doesn't matter. Okay, so one of the really cool things about the height blend is that you get this mask out the other side that tells you the things that were blended. This should probably be spot. So like, these are the sticks underneath. Super cool, but I can't put it to 32-bit the way that I can with this. Which could be a bug. Maybe it's not. I don't know. So lighten is typically the blend mode. So if I want to push this back so that it blends, I gotta take my lights, push them back, 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 back. I'm out of room pretty quick. Okay. So then I've blended these sticks over the dirt, and some of them are sinking into the dirt. So then how do I get my mask of the sticks that are in there? So I can do this. So this is basically the sticks histogram scanned, and this is the mask that's been histogram scanned. So you take whatever your blend is and you subtract what it was before you put the other piece in, and then it'll give you the difference between the two, which this is basically my sticks mask. So it was this, with a ton of stuff, and then based on the light and blend mode, a lot of those sticks got knocked out and blend into the soil instead. So here, if I take my soil down, then I start to get more of those sticks back. So there's not going to be a whole lot of normal info back here. It's going to be mostly albedo and roughness info. Like we could do a normal blend and put some info in there if we wanted, but we'll see. Just want to mock that up. So we have our soil. I'm just gonna like drag across this image. It's gonna be really weird. Okay, it's shorter distance. This need a noisy gradient to get good albedo. Maybe something like that. And then some radioactive colors in here. But I can fix that. have my noise time offset. So probably just rip the whole thing apart. Yeah. I was trying to get some variation, like per stick. But it's not really gonna work. Okay, so those are a little bit different now. What's in there? Yep, that should be correct. Trying to get a little bit more variation in each one. This will help vary like along the length of the stick so that they don't kind of all have the same pattern, right? So like this one will go kind of light, then dark, and this one is just gonna stay light. So then I'm going to do that again. I think I called it jitter color. Yeah, jitter color. Take this, different seed, different disorder. This is going to have different direction. And this will jitter the color. This is a useful node that I made that varies the color hue, saturation, and value based on an input. So I can say I don't really want to vary the hue. I could say I do, and then maybe invert the direction. Only do it a little. Don't really want to do the value too much. Maybe I do. And then saturation. So now I get some more variation on each of the sticks. They're still way too saturated in a lot of places. So I'm going to take this, do another one of these. We'll do a little bit smaller, I think. Different angle. Then do a HSL, take whatever this is and just take the saturation down and mask that in. I should download Ben Wilson's optimized graph to make sure I'm not duplicating things that I shouldn't. Just use them for. Whoa. Actually works a little bit better. Scratches. There's still a lot more work to go. But I think I'm going to call it there. We'll probably pick it up next week. I'll probably stream next week. Yeah, got to do some stuff. Take the pup out. But we'll pick this back up and we'll have no pixel processor FX map weirdness in the beginning. And we'll see if we can get something that looks really good, something that's ArtStation worthy out of it, and then how long that takes us. So thanks for hanging out with me, and we'll catch you guys on the next one.